Today's objective is to evaluate a function for an output, given an input, and then graph. Previously, you were given a function rule and given an ordered pair, and you were asked to test whether the ordered pair was a solution to the function. Today, you're going to be given a function rule, you're going to be given an input, and you need to generate the output to make the equation or the function rule true. So you're going to generate the ordered pair that makes the function true. So for this example, we're going to use the same function rule as we've used in the previous examples and notes. We're going to use y equals 2x minus 1. You may want to rewrite that as y equals 2x plus negative 1, depending on your comfort level with subtraction. And so today you'll notice that you are given 4 different inputs, and I'd like for you to generate the corresponding outputs so that we can then plot these points on the graph. So we have an input of negative 3 to begin, and so I'm solving for my y when I plug in, instead of x, negative 3. Everything else in the equation stays true. And so from here, I simplify. Negative 6 plus negative 1 is negative 7. So that is what my y equals, and that generates an ordered pair of negative 3, negative 7. Let's try it again for an input of negative 1. Here I have my original equation was 2 times x, and so instead of x, I'm telling you the input is negative 1. Finishing the equation as it's written, I get 2 times negative 1 is negative 2, plus negative 1 is negative 3. And so I'm saying that a solution to the function rule is negative 1, negative 3. And if we keep going, you could pause it here to try out the other 2 inputs on your own and resume when you're done to check against my work. I'm going to go ahead and keep going. I have an input of 1, and so my rule says 2 times x, so 2 times 1, and then plus negative 1 generates my y. 2 times 1 is 2, plus negative 1 is 1. So I'm telling you that I think 1 comma 1 is another solution. Last but not least, we have 3. So we have 2 times x, or 2 times 3, plus negative 1. 2 times 3 is 6, plus negative 1 is 5. And so I get 3 comma 5. So I've generated this list now of 4 ordered pairs that are solutions to the function 2x minus 1 equals y. And I'd like to go ahead and graph these solutions to see the outcome. And so if you remember, the x-coordinate goes with the x-axis, which is your left to right axis. Your y-coordinate is your y-axis. If you would like to think of it as y to the sky, that may help you that you need to be moving up and down for your y movement. And so negative 3 from the origin, 0, 0, which I've put in blue here, I'm going to go negative 3, which is left 3, and I'm going to go down 7, negative 7, to plot my point negative 3, negative 7 in green. I'm going to do the same for negative 1, negative 3. So negative 1 is left 1, negative 3 is down 3. I've plotted that point. 1 comma 1 from the origin, I'm going to move right 1 for the x and up 1 for the y. Last but not least, I have x is 3 and y is 5, so I'm going to move right 3 from the origin and up 5. And if you look at those points, I'd like for you to think of in your mind that this forms a certain shape. And if you see it and you connect the points, it's a, well, perhaps not by my drawing, but it's a line. Straight line would be redundant. All lines are straight. But the goal here is when you're graphing these functions, particularly in this assignment and then the next assignment, you're going to see that they should form lines. That is your check. If you do not get a straight line, then you have not graphed the function correctly, or you have not solved for the ordered pairs correctly, and that's what you'd need to go back and check. And just to remind you guys, as in the previous notes, rewrite the equations as you need it with subtraction as adding a negative. And for any variables that do not have a coefficient, it may help to place a 1 to hold that value.